Hi everyone, I'm Brian Selznick, author and illustrator of The Invention of Hugo Cabret and Wonderstruck, published by Scholastic. Welcome to the American Museum of Natural History in New York City, one of my favorite museums in the world, where much of Wonderstruck takes place. We are here today to go on a virtual tour of the museum. A long time ago, I was invited by a friend who worked here to go behind the scenes of this museum. I saw the workshops, offices, and huge storage rooms, and I was, well, wonderstruck. Looking around that day, I knew that this would be an amazing place to set a book. About 20 years passed. I created lots of other books, but after I finished The Invention of Hugo Cabret, I decided that it was finally time to write a book about this museum. Wonderstruck is about two kids, 50 years apart, who run away and end up at the Museum of Natural History. When I was writing Wonderstruck, I did a lot of research here at the museum, and what I learned was fascinating. Today I want to share some of the things I learned and bring you behind the scenes, just like my visit with my friend all those years ago. In the book, Ben and Rose, the main characters, visit many places in the museum. We're going to visit 3 of those places together. We will also meet experts who work here at the museum, and they will tell us more about the science and wonder behind the exhibits and the research that goes into creating them. In Wonderstruck, a museum is described as a collection of objects, all carefully displayed to tell some kind of magnificent story. Let's begin by meeting Ellen Futter, the president of the American Museum of Natural History. She's over in the Rowe Center for Earth and Space.
Thanks, Brian, and welcome everyone to the American Museum of Natural History right here in New York City. It was founded in 1869, and we were founded so that this city would have a great museum of natural history like ones in Paris and in London, where people had gone off on fantastic expeditions to collect absolutely spectacular items that inspire and inform about the world that we live in. You know, museums are really interesting places. You kind of think about what do they do. What we really do is try to excite people about the natural world and also help you to understand where you fit in that world. Where you fit in the larger scheme of the environment. Where do you fit as a member of one culture with respect to people of cultures all over the world? How do different objects tell you stories about that world? And one of the ways that you do that is, I bet every one of you has done it, is to go out and collect things. When I was a child, I used to collect shells, or I'd collect rocks, and every single one tells a story. It tells a story about itself, it tells a story about all the things like it, but it also tells a story about where it fits in the larger scheme. I'll bet lots of you do collecting and learn things from those stories. And of course, that's what's happening in Wonderstruck on every single page. And that's what museums do. We try to help you understand the world around you and where you fit and what's happening to that world. When you visit this museum and you see different environments, you see them exactly as they were at a particular moment in time. But they've changed. Sometimes they've been threatened by external events that have happened to the environment, or even by overuse of different areas. So we tell you all those stories, and we help you understand your world.
Welcome to the first stop on our tour, the Hall of North American Mammals, home to one of my favorite spots in the museum, the wolf diorama. In Wonderstruck it says, Ben marveled at the life-size dioramas cut like windows into the dark walls. A diorama is a 3-dimensional representation of a scene, either life-size, like the ones Ben is looking at, or miniature, like one you might have made in a shoebox for school. The dioramas here at the museum recreate nature life-size, down to the tiniest detail. Because I love it so much, I made the wolf diorama a very important part of Ben's story. The wolves are from a place called Gunflint Lake, Minnesota, which is why Ben is from there as well. Steve Quinn is the Senior Project Manager in the Exhibitions Department here at the museum, and he is in the Exhibition Lab where he is going to tell us more about how the wolf diorama was created. Steve?
We're here in the Hall of North American Mammals. I'm sitting right inside a natural history diorama as we speak. A diorama, as we display them here in the museum, is a creation. It's the intersection of art and science. It's an illusion of an actual place in nature within the walls of the museum to teach and instruct science and nurture environmental awareness and concern about vanishing wildlife. They came to be at a time prior to modern motion picture, television, certainly computer technologies, so you might think of them as one of the earliest forms of virtual reality that really are intended to reconnect us to our origins, our connections with the natural world. The wolf diorama depicts an exact site and an exact time in northern Minnesota on the shores of frozen Gunflint Lake. It's a beautiful night scene with full moonlight, cast shadows that are laid out across the snow at the viewer's feet, and across the lake a pair of wolves are loping toward the viewer. It's haunting and beautiful. It depicts wolves in pursuit of their prey. It is complete in every detail, right down to the constellations of Ursa Major and Polaris, the North Star, with a beautiful feature of Aurora Borealis in the background painting, and also depicts the accurate footfalls of wolves as they run in that characteristic loping pattern. They run with a gathered suspension. In other words, when running at a full gallop, all 4 feet are gathered under the animal at one time. And this leaves a very specific footfall pattern in the snow. The third set of prints off to the animal's right have been made by a very different animal that runs with a different pattern, and that's the white-tailed deer. So you can tell by looking at this diorama that it's a predator-prey relationship that we're telling.
Entomology is the scientific word for the study of insects. There are thousands and thousands of examples of different insects in the museum, either on display or in storage, but none of them are bigger than this mosquito behind me. This giant, upsetting Anopheles mosquito is not real. It's a model that was built over 90 years ago, and we're lucky that it's still on display. In Wonderstruck, Rose observes this mosquito as she's walking through the museum in 1927. Let's go behind the scenes with Dave Grimaldi, curator of the Division of Invertebrate Zoology, and find out what these strange insects can teach us.
Hi, Brian. I'm here in my lab. The mosquito you're standing next to is actually a model of an Anopheles mosquito, magnified 75 times. It's of one of the types of malaria mosquitoes, and it was made more than 90 years ago, made out of beeswax mostly. And the hairs, the fine hairs that you see on it, are all exactly placed, and they were made by dipping copper wires into acid to taper them to make them look like tiny bristles. It's anatomically perfect. It took years to make it, and it was part of an exhibition on diseases. A lot of people think that mosquitoes are all entirely harmful, and that's not true. There are actually some species of mosquitoes that are predatory. They feed on other mosquitoes, so they're very, very helpful. And there are lots and lots of mosquitoes that are actually pollinators. They transfer the pollen from one plant to the other so that fruit can develop. And many of those mosquitoes, for example, live in the Arctic. So there are some very, very helpful mosquitoes. When a mosquito bites, it actually punctures you with very, very fine tube-like mouth parts. And it sucks the blood up through these mouth parts. In order to prevent the blood from coagulating, sort of like when you get a scab after you get a cut, it would clog the mosquitoes' mouth parts. They actually have to inject saliva into the puncture. And it's when they inject saliva into the blood, that's when they transfer diseases from their salivary glands into the blood. And then once the diseases are in the blood, then they can multiply and actually cause the disease. But a small proportion of the mosquitoes, of the 3,000 species of mosquito, different kinds of mosquito, actually cause disease. We know a lot more about mosquitoes ever since that diorama or the model was created. We know that there are many more species than there were then. We just discovered a lot more species. We know a lot more about their DNA, and we know a lot more about the diseases that they transmit. And we also know how long they've lived on Earth. Mosquitoes have had a very successful way of life because we now know that they've lived for at least 100 million years. Here I have the oldest fossil mosquito, and it's preserved in 100-million-year-old amber from the country of Myanmar, which is near China. So mosquitoes have been around for a long time.
Our last stop today is in the Hall of Meteorites. This is the largest meteorite on display in any museum. It weighs 34 tons, that's 68,000 pounds, and it is named Anagito. I remember visiting it as a child. In Wonderstruck, a very important moment in the story happens right here. Meteorites come from outer space. When you see a falling star, that flash of light is caused by falling debris hurtling through space, and it's called a meteor. If something actually hits the ground, like Anagito, then it's called a meteorite. Anagito is actually part of a much larger meteorite called the Cape York meteorite that fell to Earth a very long time ago. Let's learn more about my old friend Anagito from Joe Bosenberg, Senior Scientific Assistant in the Department of Earth and Planetary Sciences.
This is a meteorite here, and meteorites are rocks that come from space. And as you can see on this particular rock, this has a fusion crust on it. And the fusion crust is what happens when the rock goes through the atmosphere and the skin of the meteorite actually heats up and begins to melt, and you get a dark fusion crust covering the entire surface. Anagito is an iron meteorite, and it was discovered in Greenland in 1894, and it was recovered from Greenland by Admiral Perry in 1896. And it was brought back to New York, and it sat on the Brooklyn Naval Yard for about 7 years before it was finally purchased and brought to the museum, where it now sits at our meteorite hall. Now, as an iron meteorite, this is a small slice of Anagito from the end of the large mass we have. And as you can see, this is a crystalline structure in here, and what happens is that the iron meteorite represents the core of an asteroid that has been melted. And that core, as it slowly cools down, begins to crystallize. And these crystals actually formed at about 1 degree per million years. So it takes an extremely long time to form this particular pattern. This is one meteorite. This is called a chondrite. These are the most primitive meteorites in the solar system. These are the starting blocks of the entire solar system. If you cool down the sun to the point where you can actually hold it in your hand, that would be this meteorite. So you've gotten rid of all the gas, and all you have is the solid left. That's the same composition as this meteorite. And this has built all the planets, the Earth, the asteroids, and as it turned out, also the sun. Now what's interesting about this guy is that this guy actually makes other meteorites when you begin to melt this one. So if you melt this guy, you actually get 3 other meteorites back out. First, you get this little guy. This is a little basalt. Basalt is like a lava flow, like you might see in Hawaii. And this has a very, very white, very, very fine-grained texture in it. And this is much like a crustal material, something you find at the very, very top of the asteroid after it's been melted. And that's one meteorite. Another type of meteorite, if you go down in the asteroid, is this guy. This is called a palisite. And this guy has olivine, Olivine is a mineral that's in the deep earth, and it's also peridote, which is the birthstone of people who were born in August, which is rather neat. And this is basically olivine mixed with metal. And what's happened here is that the metal and the olivine have been mixed, and they've never unmixed due to melting. Okay, they haven't separated yet. And that's a palisite. If you keep melting the palisite, you go back to the sample we were talking about earlier, the Anagito sample, the iron meteorite. And this is just the metal that's been settled out. Okay, so that forms the core. So between the three meteorites, you have core, mantle, and crust.
Well, that's all the time we have today. I want to thank Scholastic and the American Museum of Natural History, especially Joe Bosenberg, Dave Grimaldi, Steve Quinn, and Ellen Futter for taking us behind the scenes. If you want to learn more about museums, be sure to visit www.amnh.org to see all the amazing things this museum has to offer. Thank you, and remember, the world is full of wonders.